Hi, my name is John. Welcome to a video all about gasless MIG welding, or to give it its proper name, flux core MIG welding. I'm not going to show you how to weld. There's plenty of people on YouTube that'll show you how to weld. I'm going to try and show you how to set up this little MIG 180 from R Tech to run flux core MIG wire. That's three basic welding processes that can be done with this little 180 MIG welder. The first thing obviously is MIG welding. In MIG welding, MIG stands for metal inert gas. You've got a metal wire and you've got a series of holes inside there, and through there becomes an argon CO2 mix, which is used as a shielding gas, because when the metal melts and boils it reacts with the atmosphere. That's why you have an argon or a CO2 shield to stop the reaction happening. The other process you can do with this welder is stick welding or shielded metal arc welding. That's a shielded metal arc or a stick welder there. It does stick welding very well indeed. Basically, you've got a metal electrode which is covered in flux. The flux burns, produces a gas, and that's what shields a weld. Now in gasless MIG or flux core MIG, that's the wire, and the wire has a core of flux. So as the wire melts, the flux burns, produces a gas which shields the weld from the atmosphere. It also produces a slag around the outside the weld, which also stops oxidization. In straightforward MIG, you use electrode positive, earth negative. In stick welding, you mainly use electrode positive, earth negative, sometimes the other way around. With flux core welding, you use electrode negative, so this is a negative and the workpiece is the positive. I'm going to take the roller wire out of this welder and put in the flux core wire, and there's one thing you have to change inside the welder to enable it to work. I've powered the welder up just so you can see what happens inside here. You open it up, there's your roller wire, that's your wire feed motor. So when you press the trigger, that pushes wire up through the torch into that tip. That's a connector tip, that's where the power is transferred into the wire. So I'm going to take this roller wire off and put on a roller flux core. You've got to be careful when you're playing with this stuff, because the wire really wants to escape and snarl up. If it happens, it's not nice. You've got to make sure you do keep control of it at all times. There's a hole there, so we'll put the wire through that hole. I once dropped one of these, a bigger one, a 15 kilogram one, and it made a mess. Come on. Right, so that's safe now. Just scrap that bit of wire. In the end of the torch, we'll take out that tip. This is a 0.8 tip for 0.8 solid wire, and for flux core I find it better to use a 1mm tip or a 1mm contactor. This is a 0.8, is it 0.8? 0.9 kilogram roller wire. You can get up to 5 kilogram rolls. It's just a case of reversing that, adapt that for the smaller roller wire. A little bit of resistance on the end, not a lot, just enough so that the spool won't go away by itself. Once again, you've got to keep control of this wire. You've got to be in charge of it, because it soon tries to take over. Right, the wire goes into that guide. across the top of the drive rollers into that little port there, which takes it up inside the torch. You can get away using a standard roller for flux core, but you simply need to reduce the tension on the wire a little bit. Right, it'll power it up. Where's the bastard? There it is. There's enough tension on there so the rollers slip. That's about right. Like I say, that's a 0.8. I'll try with a 0.8 tip in, but I normally use a 1mm tip and see what happens with a 0.8. You don't actually need a shroud on when you're welding because you aren't using the gas, but I put a shroud on just to protect the end of the torch. You don't want all this getting covered in spatter. I mentioned earlier about the positive and negative. All you need to do inside this R Tech machine is take that wire from there and transfer it across to there, and that changes the polarity of the welder. Nice, simple. Right, so we're now basically finished inside there. Next thing is the earth lead. We've got negative and positive. Remember, we're negative live, so the ground goes into positive. That goes onto your metal bench or onto your workpiece. Basically that's it. You don't need a bottle of gas, you don't need a regulator, you haven't got the hassle of sourcing gas, storing gas. You can use this outside. Ordinary gas MIG does not like being outside because the wind blows the gas away. If you're doing a little bit of welding at home and you don't want the hassle of having to source gas, to store a bottle, to buy a regulator, gasless MIG is the way to go, or flux core welding. If you're doing artwork, you can tack things together with it quite easily. You can do structural welding with it. You can get very, very strong, decent quality welds using flux core welding. This wire is designed to weld in all positions, but it's only designed to weld in one pass. You don't do multi-pass welds with it. The controls work exactly the same. Voltage and wire speed, and it's a combination of the voltage and the wire speed that causes the ampage. I've got a bit of 3mm plate here. I'm going to run a weld down it just to get some idea of what sort of settings, because I haven't used flux core for such a long time. You're probably thinking to yourself, that looks terrible. Well, it does. But if you take the flux off it, it's not quite so terrible now. In fact, that is a good weld. If anything, it's a little bit on the cool side. It could do with slightly more power or slightly less wire. Right, for straight out of the box, they're not bad welds. You noticed I was actually dragging the torch. As an old saying, if it makes slag, always drag. This does produce a lot more fumes and a lot more spatter than ordinary gas MIG. I'm in a well ventilated shop, you've got to be aware of the fumes. I'm putting a little bit of movement in, but not very much. And I can really see the puddle, it's that's welding really nice. Once again, it's nothing to look at, but if we knock the slag off it, that is a really good weld. It'll be strong as well. This is 5mm flat bar. I've turned it up a little bit and I have ground the mill scale off. I'm going to weld it both sides and then we'll do a little bit of a test on it. The weld actually got better as I moved along, so it got a little bit warmer, but it's certainly not a bad weld. I do think it'll fall off. What I want to do is try and pull these apart. So I want that down there. Right, now we can give it a bit of a crush test, I suppose. We can get it in the vise, like a bend test. That could be the way to do it, like that. There's not much happening to it really. And that's one run flux core wire. It's starting to feel, but it's not the weld it's failed. It's failed next to the weld. The weld's intact, it's failed next to the weld. That's pretty impressive, that, for one run. I've got a fillet joint set up here. This is 0.8mm mild steel, which is basically what cars are made out of. One thing I have done is, I had an old shroud and I've cut the end off the shroud because you don't need it. And all I've done it forward so I can see the end of the electrode better, and the shroud's just going to protect the holes, the gas holes, and protect that spring. So now I've got better visibility, I can sort of see a lot better. I didn't mention before, but you stick out, you want probably half an inch stick out between the tip and the end of the wire. I've turned things down. I'm going to try running the fillet weld down there, because a lot of people that buy these will want to repair cars with them, not weld thick material. We'll give it a try. And that's going in there, no problem at all. I'm putting a very slight weave on it, but basically just dragging it straight back. Right, we'll clean that up and see what sort of job it's made. Right, I'm impressed with that, really impressed. I've got this set up as a lap joint down there, so we are going to put a patch onto a sail. And that's gone in there quite nicely. This is a very common joint on car repairs, where the bottom of the sill joins onto the body. 6mm holes, and you do what they call a plug weld, which sort of replicates a spot weld. So we'll drill holes in there, and we'll see if we can weld these together. Might need a little bit more voltage, I'm not sure, we'll give it a try and see. Straight in. And that is pretty good. I'm going to do the same weld, but without a backing piece. Like, it's not backed onto a steel bench, because I know steel benches behind car body panels. So I've got space underneath there, and I'll see if I can get that spot weld together without burning all the way through. Straight in. That wants a little bit more wire. Straight down. And that is pretty good. Okay, so up to now it's been nice, clean, shiny new metal. This is a piece of exhaust pipe, far from nice, clean and new and shiny. Cleany. Will I weld straight onto that rust? We'll find out. What I'll do, I'll put the glasses on that I can see with. Going to turn that down a little bit, it's trying to blow through. Keep pausing until the heat goes down a little bit. Nice. I don't expect it to be pretty, but I think it'll be fairly strong. It's not really unpretty. That's where I turned it down, where the hole is. It's on there. It's not gonna come off in a hurry. So you can weld straight onto rusty metal. I'll clean a bit, and then we'll try on the clean bit. That's well noticeably better, because obviously the material is a little bit cleaner. Right, I'm quite impressed with that. Quite impressed. It's actually torn the metal, the weld hasn't broke, it's torn the metal away. There's one more little test I can do. Right, it's tacked on, and I'm sort of Once again, not the prettiest weld in the world, but it's a strong weld. Tore the metal away. Right, one more plug weld, single weld. And then we'll do a test on this one. Right, I've got that one plug weld. There's no welding on the back. There's that one, it's a 5.5mm drill I used, and I've tacked 2 washers on. I'm going to put a tensile strength test on that one little plug weld. Right, that's it there, one plug weld, and I'm reasonably heavy. 15 stone at the last weigh in, and that was a while ago. Right, so that's all my weight on there, on that one miserable little plug weld. I'm not going to let go just in case. I'll bring the camera in so you can see there's no cheating going on. One plug weld, no cheating. The welded washers are welded on, but that even surprised me that. I did the same test possibly 10 years ago on straightforward MIG. I have to say I was pleasantly surprised at how well that test went. I didn't expect it to be as neat, and I certainly didn't expect it to flow as well. Really impressed. The last time I used flux core was a lot of years ago, and the way has obviously improved a lot since then. For the guy that wants to have a weld on his shed for repairing the odd thing or repairing cars and doesn't want the hassle of a bottle of gas and a regulator, or he wants to work outside where it's sometimes windy, this is ideal. People doing artwork, it's a lot easier and a lot neater than an arc welder or a stick welder. What more can I say? I'm impressed. R Tech obviously stock all these welders, and they also stock all the consumables, basically anything you need. If you do go to R Tech for anything, just mention my name. Anyway, I hope you enjoyed the video as much as I enjoyed making it. Anyway, thanks for watching.